Hello, everyone. We are starting a series of lessons dedicated to writing tests. Tests can be generally divided into two types. There's unit and integration. Unit tests are tests that verify a small part of your code, like a specific function, and integration tests verify your entire system as a whole. That means everything is connected. The database and backend send requests, and a large amount of code in different files is tested at once. In this lesson, we will write unit tests. And for this, we need the Jest library. Let's install it in all three of our pnpm packages. Oh, not test, but pnpm. We need Jest. So, yes, and since we need it in all our packages and it's a developer dependency, let's install it in our root package, JSON, in developer dependencies. And we will need Jest itself, then its types, types Jest, and also test Jest. So it works well with TypeScript too. Well, let's install. While it's installing, I'll tell you the approach when writing tests and when to write them and when not to. Well, first of all, I'll say that I don't write front-end tests at all. There was a time I wrote, and I didn't feel like they helped me in any way. So, if you ever find yourself in a situation where you realize front-end tests are needed, well, just write them. I haven't encountered this yet, because usually front-end isn't that easy to break if it's been written properly. Yeah. They depend so heavily on each other there. Yeah. And in general, it's enough that we have TypeScript, and if types align on the front end, it probably works. Yeah. Many would disagree with me on this. Yes. But nevertheless, that's how it turned out for me. As for unit integration tests on the back end and front end, specifically for some just individual functions, it's good to write tests when it's easier to check your code and how it works, instead of running it manually from various places, and it's just easier to write a test. Well, the simplest example is when you're checking something that happens only after a user registers. Then, I don't know, hypothetically adds another user's code as a friend, they do some sort of exchange, and then they need to write a review for that person. And can you imagine how many buttons you need to click to reach that state? Yes, imagine there could be positive, negative feedback, and there are certain conditions like if a review is already sent, and so on, and just checking that would take a lot of time. So it's much easier to automate this check, provide all the necessary data using code in your database, and see how it works. In other words, tests should primarily make development convenient, or write tests when you are unsure of the reliability of your code, especially when there are many variations. Again, it's easier to write tests. It's convenient to develop through tests sometimes, especially on the back end, where good tests allow you quickly conduct any refactoring. If you decide to split your models, for example, it affects everything, and you'll either have to manually verify from scratch or let your code quickly highlight issues if tests are written for key points. Again, I'll repeat, since we're using TypeScript, our code is much harder to break. And if your types align, everything usually works fine. However, tests are occasionally necessary. If you ever work purely as a back-end developer, you will always develop through tests without even looking at the front end, just running tests on your code. Okay, so having explained the general essence of tests, we can start writing them gradually. But first, let's add testing scripts to our package, JSON. So, we will have a command called test, and under the hood, it will run Jest. When we call Jest, Jest searches in this package all files that end, roughly speaking, with test.ts, and executes them. So, first, we add this command to all package.json files. We'll also add it to the shared package, JSON, right here, so. And here we'll add it to the backend. Good. We will also need to configure our Jest and create a config file in the root with the following settings. So, jest.config.js. Okay, so you can play around with this here if you need to, but this is enough for the tests to work. But this same jest.config needs to be linked in our package JSON. Let's start with the web app. So let's go to the web app, jest.config.js. And here we simply import our root. It's complaining about something here. Let's load the types. So, one moment. Oh, we're told it doesn't go into ts.config. One moment. Okay, so to stop ESLint from complaining, you can add an asterisk .config.js to ignore patterns in the root eslint.rc, so such files don't end up there. The issue was related to this file not being included in ts.config, but it is in ESLint. That's where the misunderstanding occurred. We fixed it that way. Nothing serious here. The main thing is that the config itself is here, and it's imported into the root. So, let's continue. Add this very just config. Let's add the same code to the shard. New file. Just config.js. So, good. And we also need such a file on the backend. Just.config.js. Okay? Good. We've completed the initial setup and can proceed to writing the tests themselves. So, well, it will be a clear and simple example if we write tests for our functions that check for some permissions. All right, nothing really bothers us here. It probably all works. All right, but still, it's an important part of the system, right? Checking permissions, so why not write tests for it? Let's do this and create a file, can. Well, we can mark which tests are unit and which are integration, but this is just for us. Unit.ts. There. To test these functions, we need to import them. Well, I suggest writing tests just for has permission now because it's simple and that's enough. Just knowing that has permission works. Export this function to import it in our tests. So, and import it. The final code will be like this. Oh, can.id as well, right? All right, good. And we'll test this too. Got it. So, look, all tests are built by first writing describe and passing some name there, which will be the description of all tests in this block. So, it's convenient to name it like, for example, the file itself or the function imported from there. We have more than one function, so just name it after the file. This means that in tests, it will look like a heading. That's it. Then you pass a function here, and inside it, your tests start with it. So, here the same rule applies. You write the name of your test in a line. Here, no one starts with the word shoot, but then all your tests will start with the word shoot. You can basically not write it. That's it. And then the function itself, which must execute. Jest also has this function called expect. All tests are built around it. So, a value is passed to expect, and then you say what you expect from that value. The most popular is to be, but technically there might be many things here, like there. To be false, to be truthy. Should have been invoked. Will be 0. Has such a length, and so on. There are a huge number of helpers here, and you can figure them out. We'll figure some out. Some, you'll just see when you need them. All right? And we'll go over this test. So we call the hasPermission function here with parameters. Our hasPermission takes users, and permission, not completely, but at least those fields need to be present. So here we have this as a user. It has an IDX, and in permissions, it has an array of one block IDX element. And the second argument is the permission itself, on which we check the block IDX. And, well, of course, we expect that for such a user, this function should return true. So, to be true. Could have written like this. To be true. Right. But this is somehow clearer. Good. This test, well, we've tackled it. Here. Has permission should return false if the user doesn't have this permission. That's it. An empty permission array returned false. Should return true for any permission if the user has permission all. Yes, meaning it's some kind of super admin. Right? All set returns true. And we separately check this canIdea function. Only the author can edit ideas. All right? And we pass that the user's ID is X, and the idea's author's ID is X. And here, user ID, and hacker, and author ID here is still X. And therefore, X can edit their idea, but the hacker cannot edit their idea. All right? Now that we've written these tests, you need to run them. You have several ways to do this. If you want to run the test specifically in this file, you can take its name if it's unique to your file, but it won't always be. You can therefore take, for example, its path. Copy the path. Enough of something unique for the project, for example, like this with Tails, and write, this is our test on the backend in this pnpm btest to call this script. And you can further append the path to this file, and it will specifically call this file. This is how you call it. Tests are launched. And that's it. We see that all tests have passed. If suddenly your code is broken or working differently than expected, for example, the errors will look like this. Once, and it showed you that false was expected. True came in some file it happened, in which specific line it happened, and that's it. We can deal with it. Let's go fix our test back. So, if you just ran the command pnpm btest, all the tests would run. But we only have one test right now, so it turned out the same. If you, for example, are working and only one test is failing among all, and they run for a long time, which can happen in integration tests, you can do the following. Yes, you specify the path to the file, say you need the tests, but add this prefix. After that, for example, only. And then only this test will be called in this file. But again, you can't call absolutely all files, because in other test files, all will still be called. So, if you need only and only it to run, then you need to specify the path to this file. All right, you see these were skipped. This one was only. If suddenly, for some reason, it's strange usually, but maybe you need all tests to pass except for one or two that conceptually fail, then you can add skip. Again, run the test. Now all tests will pass except for this one. This one was skipped. All right. Okay, we've covered that. Let's just write some more tests. But before we proceed, I'll tell you about a second way to run tests. This might be more convenient for you. There's an extension in VS Code called Just Runner. Yes, this one. And it allows you to run tests directly from a file in VS Code. You can click Run, and it will execute just that one. You can click Run on some other test. It will execute only that. Do whatever is convenient for you. All right? And we will write some more tests. It was worth writing tests for can or not? That's the question. But it's definitely worth writing tests for DeepMap. Because it's not certain that it works correctly. And testing it will be much easier than writing it. Because essentially, in DeepMap, we just need to pass some complex object and make sure it maps correctly. So, the test for DeepMap will be the following. If for can we decided to write many tests, then for DeepMap I suggest writing one test that checks a lot at once. All right, deepmap.unit.test.ts. Okay, and the code will be like this, and it's actually simple. So again, describe, right? the title of our tests, like it was here, can. And the name of the test, well, should map object. And it's just one test. There. Well, we can just pass such a complex object there, which essentially tests all the functionality. Here we'll check for some circular dependencies and more. Declare one function, declare a second function. And in fn1, in .fn2, we put fn1 as a property of the object again. So if we try to map something like that, we will theoretically get lost, right? And just in case, we made such a check. Declare input. Here we have an object simply as the first key object. And here we passed almost everything. Both numbers and null, and undefined, and a normal function, and a function in which you can get lost, and a string as a number, and an array of numbers, and an array of objects, and an array of both objects and numbers. Well, in general, we put quite a bit of effort so that if something doesn't work, it breaks. There. Right. Okay. And we also added some recursive object. So we have the input itself, which is simply an object and a recursive one. I set it to null here, just so that TypeScript doesn't complain later, right? And I reassign this recursive object back to the input itself. So you can get lost in the input itself. It's pretty tough. Then we simply call the deep map function. And what are we asking? In deep map, the input itself is passed. And for each of its elements, down to every depth, the key is displayed, the path is displayed. The path in this format. So object C1 null, that's the object C1 0 element. So we also get this output in the mapper. And the value itself, well, that's the specific value. So here it's 12, or for example, all this for S1 and so on. And here is our function. Specifically, we want to replace object C1 null with such a string. So we know that here in object C1 null after mapping, after this deep map, there will be this string. That is, at least we expect it. Okay? Next, we say that if we have k as u, and we encounter k and u a couple of times, it should be replaced with Mike is u. If we have k as s1, then here is such a string. And later, if we have a string or a number, we want to append plus x, xx at the end. That is, all strings and numbers should have the suffix 3x. In all other cases, the value should remain as it was. And then, well, I didn't want to manually check how this object would be structured after I complicated it like this. Because of this, you can do the following. Expect output. What this function outputs. Too much inline snapshot. Just write it like this and that's it. And save it. And run this test. When you run it, there will be the actual output here. So, couldn't manage to run it through VS Code. But let's run it through the console. Why didn't it work through VS Code? Well, they say their sprite has some error. What about this way? The test ran. We forgot to write pnpmb test. All right, let's sort out prettier. 1 second. I just read online that you can disable prettier for Jest. Let's do that. Periodically, even if everything worked before, updates to versions will start causing issues. It's normal to stumble upon something like this and check it. Not every first solution you find will work. Something might still be wrong. But we got lucky. And look, this string just inserted itself here. So when you write match in nice name shot during the test run and execution, it converts what it sees here into a string and substitutes it. Okay, good. We substituted and are checking now. Here you just need to check everything to see if there's a case where it substituted everything, but you see it substituted incorrectly. And here, for example, 3xs weren't substituted. So you understand what needs to be added here. Manually added it. You go to fix the deep map function itself. Then you return and call to verify that this matches match in a nice name shot. During subsequent runs, this match in a nice name shot will not replace its value. That is, if there is already a string here, it's frozen. But if it's not, it will insert it directly into this file. All right, so you can call it once more. And now the test will pass because everything matches. Otherwise, well, we see that this string was substituted. Here we have this scary circular function marked like this. The recursive object is also marked as circular. This is embedded within the deep map function itself that we mark such things as circular. So it's good for us that this happened. Otherwise, everything seems fine. What was objects remained objects. Arrays with objects. Everything works. Again, it might be that you wrote a test, everything works for you, but then you encountered an error that shows not everything is actually working. In such situations, it's reasonable to go and fix the function itself so it works correctly, and add some surprising case to your tests. So, yes, try to ensure tests check everything. If something was missed and users reported an issue, add it to the tests to prevent it from breaking again. And now I realize I don't like the decision we made to disable Prettier. Online, they write that you can substitute it with something else. We are currently using Prettier version 3, and it's somehow managed to be incompatible. You can set another one just for Jest. I'll experiment now and tell you what conclusion we should come to. All right, I think there's no need to worry extra about Prettier. Let it just be. It will work. Especially when Jest itself tries to add something to our files, because Prettier will run on commit and we can call it manually. And most likely, very soon Jest will work fine just with a third version of Prettier. I think there's no need to fuss here. If there's any inconvenience, well, there's documentation on Jest's website. You can just install another Prettier and pass the Prettier path right here in the Jest config. This, in general, I don't think is a problem. The only thing is that here in ESLint, I initially added it like this without quotes, but it needs to be with quotes. Otherwise, ESLint won't work. Okay. So, and I propose to also add tests to our front end for the pump get route function. It will also be a unit test, because the logic here is relatively complex. And theoretically, we could make a mistake here, so we can write tests here as well. Pump get route.unit.test.ts. Okay, and with the following content, well, we will also check our absolute paths. And to make sure it doesn't depend on our env variables, we simply hardcode this prod with env here, then import the PGR itself. In this format, because otherwise they would be overwritten with old ones here. Here. We need this order. Good. Then describe the header and the tests themselves again. And here we sort of declare our routes separately. That is, similar to how we do it in the file with routes itself. So, this route, we declared it like this. And here we name it simple route, for example. Done. We call its invocation. It should return just this string. If the route has some params, passing them, they should be inserted into this string. Should return route definition. This is the same definition we use in apt.sx. Again, for such a route, param1 and param2 with a colon should be substituted in their place. We check that the placeholders are correct, because we just have them there. Let's check them. Our types will be generated later if we need them. So, parameter 1, parameter 2 with a colon, and it should correctly return the absolute path, appending it to the initial route. Now you can run it. Okay, running tests, they work. Great. So, it seems like we've written all the unit tests I wanted. And now it would be good to run all our tests in all our packages. For this, similarly to other scripts, we'll add a script here for tests. And here we just say that we need to sequentially run the test command in all our packages. Type pnpm test. Okay, backend passed, web app passed, and if something had gone wrong, it would be clearly noticeable. But we see that many tests were skipped here. What could be the cause? It's because we forgot the only here, and that is actually bad, see? Also, we see that we have a few tests here. Let's go check in our, which one was it? Okay, these are tests for can, right? Why are there so few? Oh, because 4 lines collapsed. See? If any errors occur, they're clearly visible. The main point here is that if we see that the output is neat, there were no errors. If there was an error, let's add it. Even when calling all tests, we slow it down. Like this, backend started. And that's it. Yes, but you can't miss this. Everything is lit up red here, and you can proceed here. Right, but usually, you'll still run all tests once they are supposed to pass. If you're developing something right now, you will most likely be running some individual tests. Well, as we see, we can sometimes forget an only in our files, and we won't be checking some other tests. This is not good. That's why I suggest prohibiting this with ESLint. Let's organize this like this. Install this plugin in the root package to development dependencies. It's called ESLint plugin Jest. And we go to the ESLint RC itself. And we add our plugins. So, the plugin will just look like Jest. Let's wait for the installation and check if it works. So, installation completed, and see if it applies any default rules. Let's say we enter our can and leave only. So it doesn't complain. Let's add a rule separately for this only. Okay, we have 2 options. We can either go and add each rule ourselves, or we can say that we also extend from the recommended ESLint recommender, right? Meaning you can do it, or no. That's too redundant. We are already extending from something. Let's manually add a separate rule. Okay, good. Jest has recommended ESLint rules specifically for it, and we can add them like this, here. And then all the recommended rules will be added anyway. If something is extra, it can be disabled later. Okay, good. And right here now, if we call pnpm_lint, we will see our errors. Here we already have only highlighted. If it's hidden, there should be no linting problems now. Good. We wrote unit tests, fixed ESLint, and we can move on to integration tests. Thank you all. See you soon.